So what if the biggest roadblock in building brain-computer interfaces isn't actually a technology problem, but a translation problem?
Right.
And, what if the solution connects the quantum biology of the human brain to the molecular geometry of DNA, an ancient name for God, and of all things, a famous blue comic book superhero?
That sounds like science fiction, honestly.
It really does. Welcome, everyone, to today's deep dive. We have a genuinely fascinating and honestly kind of staggering stack of materials in front of us today.
Yeah, we do.
We're looking at two densely argued papers by an independent researcher named Zachary David Enfield. The first one is called The Organic Quantum Interface, and the second is titled The Name in the Forehead. And we also have some analytical diagrams, plus some infographics that decode pop culture iconography.
It is a really remarkable set of sources. I mean, Enfield is attempting something incredibly ambitious here. He's proposing basically a unified theory that bridges hard neuroscience, quantum physics, ancient history, and, like you said, even sequential art. Comic books.
Right. And our mission for you today is to unpack this radical theory. We're going to start in the lab, looking at his scientifically grounded blueprint for a completely non-invasive brain-computer interface. And this is all based on quantum biology.
Which is a whole wild field on its own.
Exactly. And then we're going to cross the bridge into his argument that this very interface, and honestly the biological constraints of life itself, are imprinted with an ancient mathematically precise signature.
Yeah, divine signature, as he calls it.
Right. Now, just a quick tone check before we jump in. Enfield is making some incredibly charged claims here, right? He's pulling in ancient scripture, theological texts, prophecy, and I want to make it super clear to you listening, our job today isn't to, validate his theology or endorse any specific religious viewpoint.
Absolutely not.
We are simply here to map the territory that he's laid out. We're just examining the physical architecture and the mathematical connections he draws, just to see exactly how his argument functions.
Right, impartial analysis. And the foundation of that argument really begins with a severe critique of the current state of brain-computer interfacing, or BCIs.
Okay, let's start there. Because right now, BCIs are huge news.
Oh, massive. But if we look at the industry right now, Utah arrays, Neuralink threads, those flexible polymers, they all operate on this shared assumption. And that assumption is basically, if we just engineer these synthetic devices to be small enough, or if we coat them in the right hydrogels, the brain is eventually going to accept them.
Right.
They treat the rejection of the implant primarily as a materials science problem.
That feels like the standard engineering mindset, right? Like if the machine is breaking, just build a better, smoother, smaller machine.
Exactly. But Enfield argues that this is biologically sized from first principles. The brain doesn't tolerate foreign material, and not because our current materials aren't sleek enough, but because the brain has evolved over millions of years, specifically not to tolerate foreign material.
It's doing its job.
Exactly. When a BCI is implanted and the signal degrades over time, which always happens, researchers usually blame mechanical wear, right, or classical signal noise. But Enfield points out that this signal degradation is really driven by glial scarring.
Real scarring.
Yeah. And glial scarring isn't a failure of the materials. It is a massive success of the brain's immune system.
Wow, okay, that is such a crucial flip in perspective. So all these billion-dollar tech companies are essentially trying to build, stealthier invaders? But the brain's security system is just too good.
It's way too good.
Yeah.
I mean, consider the mechanical mismatch here. You have these rigid silicon probes, right? And they have a Young's modulus, which is basically a measure of stiffness of around 200 gigapascals.
Okay, 200 gigapascals.
Right. But the brain tissue they are entering is incredibly soft. Its modulus is around 15 kilopascals.
Let me put that into perspective for you listening, because a gigapascal to a kilopascal is just a massive, massive leap. That is essentially like trying to embed a solid steel rebar into a bowl of warm Jell-O.
That's a great analogy.
Right, because every time the Jell-O moves, every time your heart beats or, you take a breath, that steel is going to cause micro tears in the surrounding Jell-O structure.
Exactly. And in the brain, those micro tears trigger an immediate biological response. The brain's immune cells, the microglia and the astrocytes, they literally rush to the site.
Like first responders.
Yep. And they don't just see the mechanical damage. They recognize the surface chemistry of the silicon or the tungsten. They read the molecular signature and realize, oh, this does not belong here. So they encapsulate it, they wall it off with this dense layer of fibrous tissue.
Which I'm assuming physically pushes the neurons further away from the electrode, right? So the signal drops.
It does that, yes, but it does even more than that. That walling off process creates severe oxidative stress. The neuroinflammation generates reactive oxygen species,
Which are what, exactly?
basically highly reactive molecules that literally corrode the active surfaces of the electrode.
Oh, wow. So the brain is actively dissolving the metal?
Yes. And even if you use flexible parylene C substrates, polymers that bend with the cerebrospinal fluid to solve that whole jello and rebar problem, you still fail.
Because it's still foreign.
Right. The flexible polymers can't hide their chemical signature. The brain recognizes the hydrophilic, protein-coded language of its own tissue. Anything else, no matter how soft it is, triggers the alarm.
So if we can't trick the brain into accepting a metal or plastic electrode, no matter how highly engineered it is, then the entire premise of modern neuroengineering kind of hits a brick wall. So what is Enfield's alternative?
He states it beautifully in the first paper. He writes, "The brain does not need a better electrode. It needs a conversation partner it can recognize as itself."
A conversation partner. I love that phrasing.
It's very precise. He's proposing that we abandon synthetic materials entirely. If you want to talk to the brain without triggering the immune system, you have to build the interface out of the exact same biological and molecular components that the neurons already use.
Okay, so if we abandon synthetic probes, the only acceptable building material left is the brain's own circuitry. But to build an organic interface, we basically have to completely unlearn how we think neurons actually talk to each other. Because Enfield is challenging the fundamental model of computation in the brain, isn't he?
Completely. I mean, most of us understand the classical electrochemical model, right?
Yeah, action potentials, firing down an axon, releasing chemical neurotransmitters across a synapse.
Pretty. Enfield doesn't say this model is wrong, per se. He says it is wildly incomplete.
Incomplete how?
Well, he argues that the classical model only describes the macroscale behavior of neural networks. Drawing on a really dense body of quantum biology research, he argues that at the scale of individual proteins, the neuron is actually a quantum optical device.
Okay, let's look at the mechanics of this, because quantum optical device sounds intense. What structures inside the neuron are we actually talking about here?
The primary focus is on microtubules. These are basically cylindrical cytoskeletal structures inside the neuron. They act like a scaffold to maintain the cell's shape, and they serve as these little tracks for transporting molecules around.
Like a structural highway system.
Exactly. But structurally, they're polymers made of a specific protein called tubulin. And this is where it gets crazy. Every single tubulin dimer, which is the fundamental building block of the microtubule, contains exactly 86 aromatic rings.
Wait, 86. Every single one.
Every single one.
And these aromatic rings, just for clarity, these are amino acids, right? Like tryptophan, tyrosine, phenylalanine, the structures with those hexagonal rings of carbon atoms?
Yes, exactly.
Yeah.
Specifically, there are 8 tryptophan, 36 tyrosine, and 42 phenylalanine rings per dimer. And what is critical about these aromatic rings is that they possess clouds of pi electrons.
Pi electrons.
Yeah. These electrons aren't tightly bound to a single atom. They're delocalized. They kind of float in a cloud above and below the ring. And Enfield argues that these aromatic rings are spaced perfectly about 1 to 2 nanometers apart to form contiguous quantum coherent conduction pathways right down the center of the microtubule.
So if the actual computation is happening inside the cell, oscillating at these quantum frequencies within the aromatic networks, then the electrical signal, the action potential that current BCIs are trying to read, that isn't the thought itself.
Right. According to this paradigm, the action potential is just the downstream residue. It's the exhaust. If the quantum optical computation is, say, the act of an author typing a novel on a keyboard,
Oh, I like this.
then the action potential is just the final printed book. Current BCIs are trying to read the printed book. Enfield wants to build a device that reads the live keystrokes.
That makes total intuitive sense as an analogy, but I have to stop you on the physics for a second. Because if you read anything about quantum computers, the giant ones that IBM or Google build, they require massive vacuum chambers, cooled to near absolute zero, just to maintain a quantum state for a fraction of a second.
Right, to prevent decoherence.
Exactly. But a human brain is a hot, wet, messy environment. It's almost 100 degrees Fahrenheit in there. How can quantum coherence possibly survive in that biological chaos?
It is the most common objection to quantum biology, and it's a vital question. How does coherence survive thermal noise? And the answer, surprisingly, doesn't come from computer science. It comes from botany.
Wait, botany, plants.
Yeah, specifically a massive breakthrough in photosynthesis research from 2006.
Okay, walk me through this.
So researchers wanted to know how plants transfer solar energy from the surface of a leaf to the reaction center with near-perfect efficiency, because it's almost 100% efficient, which shouldn't be possible classically. And they discovered something called phonon-assisted quantum transport.
Phonon-assisted. What is a phonon in this context?
A phonon is a quantum of acoustic or vibrational energy. It's essentially thermal noise, heat.
Okay.
In a classical system, heat introduces random jitter that destroys delicate quantum states. But in a photosynthetic complex, the energy takes what's called a quantum walk. Instead of a particle bouncing linearly from point A to point B, the energy exists as a wave that explores every possible path simultaneously to find the most efficient route.
But wouldn't the heat of the biological environment, like the sun hitting the leaf, collapse that wave?
See, that's the counterintuitive genius of the biological design. The researchers found that the thermal vibrations in the protein scaffold actually sustain the coherence.
You're saying the heat helps?
Yes. The heat acts as a continuous series of gentle kicks that prevent the wave function from localizing or getting trapped in a dead end. The heat is literally the engine of the coherence.
Wow. So the noise isn't destroying the signal. The noise is the medium the signal travels on.
Exactly. And the spacing of the tryptophan rings in our brain's microtubules, that exact 1 to 2 nanometer gap we talked about, is perfectly analogous to the chromophore networks in those photosynthetic plant proteins.
That is wild.
It is. Furthermore, the core of the microtubule is highly hydrophobic. It physically repels water.
Oh, so it keeps the water out.
Right. And that lack of water acts as an insulating shield, protecting these delicate quantum channels from the messy aqueous environment of the rest of the cell.
Okay, so if the brain is operating on this isolated quantum level inside the microtubule, how does it connect back to the classical chemistry we actually know about? Like, when a chemical neurotransmitter crosses a synapse, how does it talk to a quantum optical network? It sounds like two completely different languages.
They are completely different languages, but they're bridged through a very specific physical mechanism called a Cation-pi interaction.
Cation-pi. Okay, break that down for me.
Let's take acetylcholine, which is a major neurotransmitter involved in memory and learning. When acetylcholine enters the synapse, it has a positive charge. That's the cation.
Right.
When it binds to its receptor on the postsynaptic neuron, it doesn't just, bump into it like a key in a lock. The positive charge of the neurotransmitter docks directly onto the negative electrostatic surface of the aromatic pi systems.
Wait, specifically onto the tryptophan and tyrosine?
Specifically onto the tryptophan and tyrosine residues in the receptor.
So the chemical is literally plugging its positive charge directly into the pi electron cloud of the quantum network.
Yes. It is the physical transduction event. The binding of the classical chemical alters the geometry of the pi electron cloud, which instantaneously cascades down that 1 to 2 nanometer aromatic highway into the microtubule. They aren't parallel systems. They are a continuous, physically coupled architecture.
Okay, my mind is slightly blown, but practically speaking, if this quantum architecture is happening in every neuron and you want to build a BCI to read it, geography becomes your next major hurdle.
Definitely.
You can't just stick this interface anywhere in the brain and expect to read complex thoughts. So Enfield targets a very specific region.
The prefrontal cortex. Why are we zooming in there?
Because the prefrontal cortex, specifically the dorsolateral and ventromedial regions, is the anatomical seat of executive function. It is where your working memory operates, where you plan, where you abstractly reason.
Right, the high-level stuff.
Exactly. Most current BCIs, like the ones in the news, they target the motor cortex. But if you put a chip in the motor cortex, you are really just reading the command to move a thumb or an arm.
You're reading the letter after it's already been dropped in the mailbox.
Exactly. But if you access the prefrontal cortex, you are accessing the cognitive architecture that precedes the action. You're reading the decision as it crystallizes.
Okay, but there's a problem here. The most complex computational layers of the prefrontal cortex are deep inside the tissue. And if Enfield's entire premise is that we cannot pierce the brain without causing an immune reaction, how do we reach the deep layers without digging?
He exploits this brilliant, naturally occurring anatomical feature. The primary computational engines in this region are layer V and layer 3 pyramidal neurons.
Layer 5 and 3, okay.
And their cell bodies are deep in the cortex. However, they have these massive elongated structures called apical dendrites.
Apical dendrites.
Right. And these dendrites reach all the way up from the depths to the pile surface. which is layer I, the very, very outer membrane of the brain.
Oh, I see. It's like a massive tree whose roots are deep underground, but its branches reach all the way up to the top of the forest canopy. So if you want to know what the roots are doing, you just have to touch the highest leaves.
That's a perfect way to visualize it. And these apical dendrites aren't just passive biological cables. They are densely packed with microtubules that are actively performing that quantum optical computation.
So they're carrying the live signal right to the surface.
Yes. Which means a BCI doesn't need to penetrate the neural tissue at all. It can rest gently on the absolute surface of the brain, completely avoiding physical trauma while still having direct high bandwidth access to the deepest cognitive circuits.
Okay, so we have our target location, the surface of the prefrontal cortex, and we know we need a biological conversation partner to avoid the immune response. So what is the actual building material Enfield proposes for this surface-level device?
He proposes an engineered amyloid scaffold based on the sub-35 yeast prion.
Hold on. If you say the word prion or amyloid to anyone who studies neurology, alarm bells immediately go off.
Oh, absolutely.
Those words are instantly associated with horrific degenerative diseases. Alzheimer's, Parkinson's, mad cow disease. I mean, they are caused by misfolded proteins that clump together and destroy brain tissue. Is he seriously suggesting we introduce a prion into a healthy human brain?
I know it sounds totally counterintuitive, but there is a vital distinction here. The amyloids associated with human pathology like beta in Alzheimer's are toxic because they misfold natively within our own biological environment, and our immune system responds catastrophically to them.
Right, our body attacks itself.
Exactly. But sub-35 is a yeast protein. It evolved in fungi. In yeast, it doesn't cause disease. It functions as a heritable epigenetic element. It's actually a mechanism for survival and adaptation for the yeast.
Okay, but why is a yeast protein safer than a human protein?
Because the mammalian brain has absolutely no evolved immune vocabulary to recognize it. It is so foreign, so biologically alien to our evolutionary lineage that the microglia and astrocytes simply ignore it.
Wait, really?
Yeah, it doesn't trigger the walling off process. It is immunologically invisible.
It hides in plain sight. That's incredible. But is a yeast protein physically strong enough to act as the hardware for a computer interface? I mean, it's just protein.
Amyloid fibrils are structural marvels. They form what is called a cross-beta sheet spine. It's essentially a quasi-crystalline structure.
Okay.
They possess a mechanical stiffness comparable to nylon or silk. Their Young's moduli sit in the range of 3 to 20 gigapascal.
So it's soft enough to bend with the brain's 15 kilopascal tissue without slicing it like the steel rebar.
Exactly. But it's robust enough to maintain a perfectly stable crystalline architecture for computation.
Okay, so we have this tough, invisible yeast protein string, but a string isn't a computer. How does it actually communicate with the quantum microtubules in those apical dendrites?
This is where Enfield introduces his specific engineering modification. He takes that sub-35 backbone and proposes inserting tryptophan and tyrosine residues into it at perfectly spaced periodic intervals.
The aromatic rings again?
Yes. Specifically, he dictates placing them exactly every 4.8 angstroms along the fibril axis.
Okay, why that exact measurement? Why 4.8 angstroms?
Because 4.8 angstroms matches the exact structural period of the beta sheet turn in the amyloid. By placing an aromatic ring precisely at that turn, you create a continuous overlapping column of pi electron clouds.
So you are manually constructing a quantum wire.
Exactly. You're building a wire that perfectly mimics the brain's native aromatic network. And that 4.8 spacing falls right into the optimal 3.5 to 5 angstrom range required for quantum coherent pi decoupling.
You are basically building a custom extension cord, and the prongs on that cord are mathematically spaced to perfectly match the microscopic sockets in the brain's own biology.
That is exactly what it is. And this naturally transitions us into how the entire device is layered. Enfield outlines a 6-layer non-invasive ambient architecture. The source actually provides a detailed infographic breaking these down.
Let's walk through the mechanics of these layers because this is fascinating. So layer 1 is the quantum coupling layer. This is the engineered amyloid scaffold we just discussed. It sits right on the cortex, nanometers away from the dendrites. But if there are no wires physically piercing the brain, how does the data jump the gap?
It communicates through a well-documented quantum phenomenon called FRET, F-R-E-T, which stands for first-to-resonance energy transfer.
Okay, think of fret like placing two tuning forks close to each other. If you strike the first tuning fork, it begins to vibrate at a specific frequency. Even though it is not touching the second tuning fork, the acoustic energy travels through the gap, and the second fork begins to vibrate at the exact same frequency.
Right. And fret does this with electromagnetic energy instead of sound. It transfers energy via non-radiative dipole coupling.
Non-radiative meaning it doesn't emit a photon, it just passes the field energy directly.
Yes. So across a gap of just 2 to 5 nanometers, the quantum state of the brain's microtubules couples directly to the engineered quantum state of the amyloid scaffold. The information bridges the physical space seamlessly.
Wow. Okay, so that's layer one. Layer two is biomineralization. What is happening here?
This layer acts as the sensor array. Enfield proposes incorporating nanodiamonds containing nitrogen vacancy, or NV centers.
Nitrogen vacancy center.
Yeah, an ND center is essentially a microscopic defect in a diamond crystal lattice where a nitrogen atom replaces a carbon atom next to a vacant spot.
A deliberate flaw.
Exactly. And these defects are incredibly sensitive to magnetic fields. They can detect the minute magnetic fluctuations generated by the aromatic network. Furthermore, they can harvest biophotons.
Biophotons? You mean the brain emits light?
Yes, ultra-weak emissions of light are naturally produced by metabolically active brain tissue. The NV centers can detect them.
That's crazy. Okay, layer three is the piezoelectric layer.
Right. This layer translates physical movement into electrical data. The amyloid structure itself is naturally piezoelectric, meaning it generates a small electrical charge when it is subjected to mechanical stress.
Like being squeezed.
Exactly. And by doping this layer with inorganic nanocrystals like barium titanate, the scaffold can capture the nanoscale pressure waves, the literal physical swelling of an action potential firing in the dendrite.
So it feels the thought.
It does.
Okay, layers 4, 5, and 6 seem to be about moving the data out to the user. Layer 4 is power management and encoding, where an onboard AI translates those quantum analog signals into digital spike timing data.
Right.
Layer 5 is wireless near-field communication, which broadcasts at gigahertz frequencies right through the skull, which completely eliminates the need for wires breaking the skin.
Crucial for avoiding infection.
Absolutely. And finally, layer 6 is the external AI decoding layer. So this sits outside the body, maybe on a wearable, using deep learning to translate the raw signal into usable interfaces.
But you know, the most elegant engineering in this entire blueprint is how Enfield solves the power bottleneck.
Oh, the power. Because if you build a device that sits permanently on the brain, it cannot rely on a lithium-ion battery. You can't perform brain surgery every 5 years to swap out an Apple Watch battery pack.
No, you can't. So Enfield proposes a trimodal ambient energy harvesting system, meaning it generates its own power indefinitely from the body itself.
Let's break down the mechanics of these three power sources, because honestly, this is where physics and biology truly merge. The first is beta-voltaic power.
Beta-voltaic energy involves harnessing the decay of radioactive isotopes.
He's radioactive.
Yeah. Enfield proposes building tiny amounts of tritium, or carbon-14, directly into the amino acid structure of the scaffold. And as these isotopes naturally decay, they release beta particles, which are high-energy electrons.
But wait, placing radioactive material directly on the human brain sounds like a literal recipe for severe radiation poisoning.
If it were gamma radiation, absolutely yes. But tritium emits low-energy beta particles that have a maximum penetration depth of only a few micrometers in biological tissue.
So it doesn't go far.
Right. The radiation is entirely localized within the scaffold itself. It never reaches the brain tissue, but it provides a continuous, decades-long baseline of microwatt power to keep the sensors active.
That is incredibly clever. Okay, the second power source relies on the piezoelectric layer we just mentioned. How does it harvest power from movement?
Well, your brain is in constant rhythmic motion. With every single heartbeat, a pulse of blood enters the skull. With every breath, the cerebrospinal fluid fluctuates. The cortex physically deforms and expands by microscopic amounts constantly.
Right, pulses.
Exactly. The piezoelectric materials in the scaffold are squeezed and stretched by this relentless biological rhythm. So it's harvesting that mechanical kinetic energy and converting it into a steady electrical current.
It literally runs off the pulse of your life.
It does.
And the third source is thermoelectric power.
This utilizes something called the Seebeck effect. The brain is the most metabolically active organ in the body, right? So it generates a tremendous amount of heat. However, the ambient temperature of the scalp and the outside of the skull is cooler.
Naturally.
This creates a persistent 2 to 7 degrees Celsius temperature gradient across the device.
And how does a temperature difference create electricity?
In a thermoelectric material, heat acts basically as a pressure. It pushes charge carriers' electrons from the hot side toward the cold side. As the electrons migrate away from the hot brain toward the cooler skull, they create a voltage difference. The device continuously harvests power simply from the heat of your own metabolism.
So it runs off microscopic atomic decay, the mechanical pulse of your heartbeat, and the literal heat of your thoughts, all working in unison so it never, ever requires an external power source.
Yeah, exactly.
Okay, if an interface like this actually existed, reading the quantum prefrontal cortex with zero immune rejection, powered forever by your own body, what does it actually enable us to do?
Because it accesses the quantum optical layer at the single dendrite level, it isn't just guessing what physical action you want to take. It could decode semantic intent.
Meaning?
It could read active working memory, the formulation of abstract concepts before they are even verbalized. But more profoundly, because the Pfeiffer-Arret coupling is bidirectional, meaning energy can flow from the scaffold back into the brain, it could write information.
Write information into the quantum state of the brain.
Yes. Enfield suggests it could deliver precision-targeted quantum optical perturbations to reverse engineer pathological attractor states.
Give me an example of that.
So if a patient suffers from severe PTSD or major depressive disorder, the physical neural network is basically trapped in a rigid pathological loop. By altering the quantum coherence at the microscale, you could theoretically dissolve that loop at the computational root before the depressive or anxious state fully manifests in the classical chemistry of the brain.
That is just staggering. I mean, the biological and engineering blueprint Enfield lays out here is a massive paradigm shift on its own.
It really is.
But if the brain's microtubules and our DNA are mathematically optimized for this exact quantum frequency, it forces us to ask, where did these structural constraints come from? Why 4.8 angstroms? Why is the biological vocabulary built this exact way?
And that question is exactly where the paper shifts gears entirely.
Right. Enfield argues these aren't just random evolutionary physical limits, and this is where his work takes a breathtaking thematic pivot. He steps away from the material science and argues that this entire quantum architecture is imprinted with a mathematically precise, prophetic signature.
It is a profound shift in the tone and scope of his work. He moves to his second paper, The Name the Forehead. And to introduce this transition, he anchors his argument using a very unexpected cultural artifact.
Which is?
The character Dr. Manhattan from the 1986 comic book series Watchmen.
John Osterman, the blue, glowing, omnipotent physicist. Now, to anyone listening, jumping from quantum brain interfaces to a comic book might seem absurd, but the specific lore of this character perfectly encapsulates the mathematical point Enfield is trying to make. Let's look at the specific choice John Osterman makes regarding his identity.
So, in the narrative of Watchmen, Osterman is a quantum physicist who is accidentally disintegrated in a particle physics experiment.
Right.
And he manages to reconstruct his own physical body at the atomic level, returning as this being who experiences all time simultaneously and can manipulate matter at will.
Basically a god.
Exactly. When the government decides to market him as a superhero, they hand him a costume that features a flashy, multi-ringed atomic logo on the helmet.
The classic 1950s atom logo. It looks like a little planetary solar system.
Right. And he refuses it. He calls the helmet absurd. He states, "If I'm to have a symbol, it shall be one I respect."
Makes sense.
As a physicist who understands the fundamental nature of reality, he rejects the complex artificial logo and chooses the Bohr model of a hydrogen atom. One central dot representing a single proton, and one ring representing a single electron.
Hydrogen.
And then he takes his finger and effortlessly burns this perfectly simple geometric shape directly into his own forehead.
He permanently marks the seat of his intellect with hydrogen. Why does Enfield care so much about hydrogen?
Because of what hydrogen represents purely objectively. Scientifically, it is the first element. It is atomic number 1 on the periodic table, the origin point of all other elements in the universe.
The first.
Right. And linguistically, the concept of the first is the alpha. Furthermore, because it consists of just one proton and one electron, it is the minimum viable unit of matter, the absolute smallest component of physical reality.
Okay.
And the linguistic concept of the smallest is an iota.
The alpha and the iota. The first and the smallest.
Exactly. When you combine those two concepts into Greek characters, you get iota alpha, or IA. And this is where Enfield makes his leap into the historical and theological record.
So the scientific IA of fundamental matter perfectly mirrors an ancient, historically attested name of God.
Enfield cites the historical records of the 5th century bishop and scholar Theodorus Cyrus.
Okay.
Theodore wrote a theological text called Questions on Exodus. In this text, he wasn't just theorizing, he was documenting the actual linguistic practices of his era.
Like an anthropologist.
Yes, he recorded that while the Samaritans pronounced the divine name as Ayabe, the Jewish communities used the distinct two-letter form of the name, Yod-He. And Theodore had explicitly recorded that this specific two-letter name was pronounced and transliterated into Greek as I iota alpha.
Just to clarify for anyone familiar with biblical history, Yod-He is not the four-letter tetragrammaton, the YHWH.
Correct. Yod-He is the contracted, distinct two-letter form of the divine name. It appears frequently throughout the Psalms. When you hear the word hallelujah, it is the imperative command to praise Yah, the voiced pronunciation of Yod-He.
And Enfield demonstrates that this specific phonetic translation didn't just die out in the 5th century. It survived perfectly intact into the bedrock of English translation, specifically pointing to the 1539 Great Bible.
The Great Bible was the first authorized edition of the Bible published in English, commissioned by King Henry VIII. In Psalm 68.4, the text commands the reader to praise the Creator by his specific name. The 1539 translation renders that verse exactly as, "Praise ye him in his name, I-A." Capital 1, capital A.
Wow.
Later translations like the Geneva Bible or the King James altered it to J-A-H. But that foundational English text preserved the exact iota alpha spelling.
Think about the massive synchronicity here. Dr. Manhattan, a fictional character who perceives reality purely at the quantum level, burns the symbol of hydrogen, the alpha and the iota of matter, into his forehead. And in doing so, he literally carves the ancient, historically documented name of the creator, IA, onto his face.
It's crazy. And Enfield argues that Alan Moore, the writer of Watchmen, had absolutely no theological intent when he wrote that scene. Moore was writing a secular deconstructive sci-fi story.
Right.
He simply asked himself, what is the only symbol a godlike physicist would respect? By purely following the logical constraints of fundamental physics, Moore arrived at the exact same answer as 5th century theology. Enfield views this as evidence of an underlying architecture, the Spirit authoring truth through an unwitting secular vessel.
And this is where the argument shifts from historical linguistics into hard mathematics. Enfield takes this two-letter name, Yod-He, or IA, and subjects it to a strict mathematical analysis that circles all the way back to the biological constraints of human DNA. He introduces a concept he calls the rule of regnal pairs. How does this rule function?
It is a principle derived from legal and historical traditions regarding how you handle pairs of numbers that represent a singular identity. Think of a dynastic partnership or the elements of a legal seal. The rule dictates, concatenate, do not sum.
Concatenate meaning you place the numbers next to each other rather than adding them up.
Precisely. If you have the Hebrew letter Yod, which holds a numerical value of 10, and He, which holds a value of 5, if you sum them mathematically, you get 15.
But in doing so, you destroy the order. You lose which value was primary and which was secondary.
Exactly. Their distinct identities are blended and erased. By concatenating them into a standard decimal format, you preserve both the hierarchy and the individual values. So 10 and 5 become 10.5.
10.5. When I read what that specific number correlates to in human biology, it genuinely stopped me in my tracks.
The number 10.5 corresponds perfectly to the foundational geometry of human life. In molecular biology, the canonical B form of human DNA, the classic double helix structure, does not twist arbitrarily. It completes one full helical turn exactly every 10.5 base pairs.
Let me make sure the physical mechanism of this is totally clear to you listening. The two-letter Hebrew name of the creator, handled under a standard legal convention of concatenation, equals 10.5. And the physical structure of our genetic code, the literal blueprint of our biology, spins at a mathematically rigid rate of exactly 10.5.
Yes. And Enfield emphasizes that this 10.5 non-integer is not a coincidence. It is a structural necessity for life to exist at all.
Why is that?
If the DNA helix twisted at a perfect integer, say exactly 10 base pairs or exactly 11 base pairs per turn, the geometry of the spiral would be symmetrically close. It would be transcriptionally sealed.
Meaning the biological machines in our cells wouldn't be able to read it.
Exactly. The RNA polymerase enzymes need to physically access the major and minor grooves of the DNA to transcribe the genetic code into proteins. The fractional non-integer twist of 10.5 creates an asymmetrical opening in the geometry. It is the precise physical constraint that allows the biological code to be unzipped, read, and inherited.
Wow.
Without that exact decimal, life cannot propagate. The numerical value of the name, Yod-Heh, maps perfectly to the torsional geometry required for biological existence.
But Enfield doesn't stop with the Hebrew alphabet. He takes that same rule of regnal pairs and applies it to the Greek and English translation of the name, the IA.
He applies the ordinal constraint. In the standard alphabet, I is the 9th letter, A is the 1st letter. Following the strict rule to concatenate rather than sum, the values 9 and 1 become 9.1.
So we now have two distinct numerical values derived from two different ancient linguistic systems using the exact same mathematical rule. The Hebrew biological value is 10.5. The Greek-English ordinal value is 9.1. What does Enfield do with these two numbers?
He lawfully composes them. He brings the two halves of the identity together. He adds the biological or Hebrew value with the ordinal or Greek value, 10.5 plus 9.1.
And 10.5 plus 9.1 equals 19.6.
And 19.6 is a highly specific physical constant in our universe. 19.6 meters per second squared is exactly 2g, twice the standard acceleration of gravity on Earth.
2g. Okay, why is a gravitational pull of 2g so significant to this theory?
Because according to aerospace medicine and developmental biology, 2g is the empirical hard upper limit for human embodied life.
Wait, really?
Yes. If you expose a human body, and specifically a developing embryo, to a sustained gravitational field above 2g, physiological coherence breaks down entirely.
What actually happens to the body physically at that threshold? Like, what breaks?
The mechanisms of mechanotransduction, which is how cells sense physical forces and translate them into chemical signals, they begin to fail. The circulatory system cannot maintain blood pressure against the hydrostatic column. But more importantly, embryonic development ceases to function properly.
Because it's too heavy. Essentially, yes. The physical forces pulling on the cellular structures prevent the proper formation of organs. Human life simply cannot propagate or survive long-term at anything above 19.6 meters per second squared.
Let's synthesize the magnitude of this claim. The mathematical constraint of human DNA, 10.5 base pairs, and the linguistic ordinal constraint of the name 9.1 add up perfectly to 19.6, which happens to be the absolute gravitational ceiling for human survival. Enfield is arguing that the name of the creator literally outlines the microscopic geometry of our DNA and the macroscopic gravitational boundaries of our physical existence.
That is the core of his thesis. He is arguing that nobody coordinated this. The molecular biologists measuring the helical pitch of DNA in a laboratory, they didn't consult the ancient theologians translating Aramaic.
Right.
And neither of them consulted the aerospace engineers spinning centrifuges to calculate the limits of human gravity. Yet when the data from these completely disparate fields is handled under a single lawful rule, they all converge on the exact same structural architecture.
And this mathematical convergence brings us right back to the image of Dr. Manhattan burning the symbol into his forehead. Enfield links this act in a comic book directly back to the book of Revelation.
He points specifically to Revelation chapter 22, verse 4, which describes the final state of humanity. The verse states, "And they shall see his face, and his name shall be in their foreheads."
The forehead.
Yes. The forehead in ancient scripture is always the seat of identity and intellect. It is where the high priest of Israel wore the golden plate declaring holy to YHWH.
Okay, yeah.
So when Alan Moore conceptualized Dr. Manhattan, a character who transcends linear time and perceives the quantum substrate of reality, he had in place the scientific iota alpha, the hydrogen symbol, directly onto his forehead.
Which is the name.
Exactly. Enfield views this as a profound visual fulfillment of the prophecy. A secular author, guided purely by the structural logic of physics, placed the exact ancient name precisely where the text said it would be. It is a stunning observation. And to close the loop on this massive architectural theory, Enfield ties this entire mathematical and theological framework right back to his original paper on the brain-computer interface.
He examines the acronym itself, BCI. He applies the exact same English ordinal concatenation that we used for IA. B is the second letter of the alphabet, C is the third letter, and I is the ninth.
239.
Yes, 239. And Enfield points out several astonishing convergences with this specific number. First, in orbital mechanics, 239 anomalistic months forms a highly precise gravitational cycle.
Let me clarify that term for you listening. An anomalistic month is the time it takes the moon to move from its closest point to Earth's perigee back to its closest point again. It's a measure of gravitational resonance.
Exactly. It's a fundamental physical cycle. Second, if you look at Strong's Concordance, which is the exhaustive standard reference index that maps every original word in the biblical text to a specific number. Entry number 239 in the Greek dictionary is the word Alleluia,
which translates literally to praise Yah, the very name, the IA, that we have been tracking through the DNA and the gravity.
Yes. Enfield suggests that BCI, the brain-computer interface, specifically an interface operating organically at the quantum level, is the exact technological domain where this divine signature directly intersects with human cognition.
So Enfield isn't just designing a medical device to help people, check their email with their thoughts. He genuinely believes he is mapping the underlying code of reality itself. He's arguing that the brain speaks a quantum optical language built on aromatic rings, governed by genetic twists and gravitational limits, that all explicitly spell out a singular foundational signature.
To Enfield, the universe is not a collection of separate, isolated silos. We tend to put molecular biology in one box, ancient theology in another, astrophysics in a third, and pop culture in a fourth. Enfield's work is an aggressive attempt to tear down those walls and present a reality that is a single, fully integrated structure.
We have covered a truly massive amount of ground today. From the failure of metal electrodes and the brute force of gigapascal stiffness causing glial scarring, to the delicate quantum tunneling of tryptophan inside the warm, wet, hydrophobic cores of our brain cells. We've traced the 10.5 twist of the DNA helix, the 2G gravitational limit of human biology, the blue forehead of a comic book god, and the ancient linguistic translation of a 5th century bishop.
It's a lot to process.
It is. If you've ever felt overwhelmed by how fragmented modern knowledge is, think about how you view information in your own life. We are conditioned to assume that a discovery in a physics lab has absolutely nothing to do with a verse in an ancient scroll or a panel in a graphic novel. Enfield's work challenges you to look at the universe as a hyper-connected architecture where absolutely nothing is an accident, where a grammatical rule applied to ancient Hebrew mathematically predicts the shape of your genetic code and the structural limits of gravity.
It's a beautiful way to see the world, really.
It truly is. So if Enfield is right, if fundamental constants like DNA geometry and standard gravity literally encode a name, and if our brains process reality through a quantum substrate tuned perfectly to that exact frequency, then it raises a profound question about the nature of innovation. Are we ever actually inventing technology like the brain-computer interface? Or, as we dig deeper into the quantum layers of our own biology, are we simply remembering the blueprint of our own design?
Wow. That's a profound thought.
Something for you to chew on next time you read a comic book, hear about the newest tech implant on the news, or just look at an X-ray of your own body and wonder what else is hiding in the deep, mathematically perfect waters of human biology. Thanks for taking the deep dive with us.